Folks, another modified contest problem where we're dealing with positive integers. We don't want negative integers because we would be dealing with fractions here. Remember, a negative exponent would result in a fraction. It's not in the spirit of this divisor thing we're doing. Now, we're looking for the smallest natural number such that n raised to the n power has at least 720 divisors. Some people call these divisors factors. Now, super useful fact is this result. It says p is prime, a common letter for a prime number. If p is prime, p to the k has exactly k plus 1 divisors. And let's just list them for a concrete example. Let's consider prime number 7 raised to the 4th power. Okay, now what I'm going to do is I'm going to list the divisors right after it here. So 1's a divisor of any number. 7 to the 1st power. 7 squared. 7 cubed. And 7 to the 4th. And so you can count them. There's 5 divisors here. Okay, there's 4 plus 1 divisors. 4 plus 1 equals 5 abbreviated divisors, div. Okay. This holds for any prime. Okay, now let's move along. Now, just trying to get a grip here, notice that this this is in the form that we're interested in. This is in the form n raised to the n, right? Now you go, why did I pick 727? Well, 727 is a prime. And so it's amenable to this result that we just established right here. Now you may wonder why I started with 727. Well, I did look at 700, but look, 700 is even. It's not a prime number, right? And let's see. No, sorry. I'm talking about the wrong numbers here. I tried 720 itself. So 720 is certainly an even number, not a prime number. 721 is actually divisible by 7. That's easy to see. It's 721 is 7 times 103. 722 is another even number. 723. So I was searching. You got to scratch around. 723 is divisible by 3 because the sum of the digits is divisible by 3, and so on. 724 is an even number. 725 divisible by 5. Okay. So you see, there's some work required here. I just showing you the kind of the result of it. And then 726. I tried all of those, right? But none of those would have the condition that we're interested in. Okay. So they would break out into something else, and you can verify that if you want. But that's why I chose 727, because it's the first prime number. How do I know 727 is prime? If you consider the square root of 727 and all the prime divisors less than that, none of those prime divisors will divide 727. Again, there's some work required there too that I'm leaving out. But 727 is a prime, and it has 728 divisors. So it's in this form, right? But is it the smallest? We're looking for the smallest natural number with this property, okay? So we do have a number, but our question is it the smallest? Okay, so we do have one number. Now, also I looked at these cases where you had 3 prime factors, but based on this result right here, you would have 31 times 31 times 31 divisors, right? Again, I'll abbreviate that. And certainly that is much larger, without multiplying it out, that is much larger than the 720 that we're talking about, right? So you see, this leads you to believe that there's no way you can work with more than a pair of primes. Certainly the same kind of stuff would be happening with 3, 5, and 7, and the exponent would be even bigger. And notice how 2 times 3 times 5 is 30. And the result that we used right here, if this bothers you slightly, is the result, what do we want to call these things? A to the, got lost here. All right, so let's take a look right here, folks. This result right here is true simply because if you have a raised to the m times b raised to the m times c raised to the m, by the commutative property of multiplication, this is ABC quantity raised to the m power. Okay. Again, it's a result that's kind of memorized a lot, but the reason it's true is because you can commute. You can reverse the order of multiplication, switch it around. Okay. So that's why this is true, and it's in the form, but it would be much larger than the 720 divisors that we're interested in. Okay, so that leads us to consider just prime factorizations of this particular form, where p is an odd prime. P is an odd prime. Now, so again, hopefully this is all kind of motivated well enough by the previous examples. 2 is the smallest prime. We want as few divisors as possible, so we're certainly going to include 2. Okay, and the rest of this is just getting it in the form. Notice this is in the form n raised to the n, right? It's just our n is equal to 2 times p. Okay, now again, as before, we increment the exponents, okay? And that's exactly what we did right here. So we have any number in this form is going to have 2p plus 1 quantity squared divisors, okay? All right, so let's just check out some possibilities here. Let's check out p equals 5. So p equals 5. And again, y'all, I'm using this result right here. That would lead to 11 squared, right? But 11 squared is certainly less than this, what was it, 720 that we're interested in? We're interested in 720 being less than at least 720. So it fails, 5 fails. Okay, now let's try the next prime, which would be p equals 7. Okay, that would lead to what, 15 squared? And I'm just going to write down that, yeah, just like before, less than 720. Next prime in the list would be prime number equals 11. Okay, so in a similar, you would have 11, you would have 23 squared. I forgot what that is, but I know it's less than, maybe it's 529 or something, but it's less than 720. Okay. And then let's try 13. P equals 13 is 26 plus 1 is 27, so that would imply 27 squared. And that's actually greater. I think 27 squared, I wrote it down somewhere. 27 squared is 729, okay? So 729 is greater than the 720, all right? So we know that P is equal to 13, and that means that our number would be, and I'll just write it like this just for emphasis, it would be 2 times 13 elevated to the power of 2 times 13. Okay, and that would be 26 raised to the 26th power. Righty? 26 raised to the 26th power. Now, what was the question? It said find the smallest natural number n such that n to the n has at least 720 divisors. Well, we've showed that n is equal to 26. Without having 26 to the 26 is an unpronounceable huge number, you know. And I'll just write it up here for reference. 26 raised to the 26th power has at least 720 divisors, because what do we show? We showed that it had 729. Okay, it has 729. So 20 to the 26 possesses 729 divisors without us necessarily being able to or want to enumerate them. Okay. All right, y'all. I thought it was kind of a fun problem. Some reasoning going on there. Prime factorization is always super useful, ruling out certain possibilities. But the answer is n is equal to 26. Hope you enjoyed.